I don't know if it will feel like generating the code straight away, or it will just respond in text first. No idea. No one knows. I'm surprised it does anything at all. Styling. Yes, it's generating the code. Okay, so we have the spectrograms. Yep, that's fine. Images, yes. So it will be the same. Then we have a section on model results. And that one is controlled by the JavaScript. And it did change the text as well, so it did a pretty good job. At least that's what it looks like. And we currently have 150 lines of code, and then 131. What did we get rid of? Yeah, we have 196. Well, okay, I think it cut the description to be a bit shorter, but I don't see the results on the page. We're having error. Is it line 60? I don't understand. It's line 35. No, that's the error. The error is actually line 63. We have the JavaScript. There's some problem in the JavaScript, it seems. The results section. I have a results section. The results container has a different name. That's a bit weird. That's a bit weird. Generating what? I need to regenerate. Have to make sure I keep my hands below like a certain level on the screen, because when I go higher, the volume goes higher. So the error you're encountering. Inspected that results. Where's that function? Get results. Okay, that's the same. No, that's just adding more logging. Check the backend response. Display. Yeah, so more debugging is always good. Well, not really, because it just becomes cumbersome. Want to keep the code to a minimum. Display. Just, yeah, adding console logs. Pretty sure we're having an issue with the HTML. Expected an array, but got something else. Okay. Expected an array, but got something else. I think we're missing something from the HTML. Another good thing about the section EEG Spectrograms. Then we have model results. Are we missing something? Are we missing something in the HTML? I don't know. Yeah, when you do this with your hands, it's all getting mixed up if you can't see the hands properly. Or sometimes it's when the hand is on an angle, it's detecting left for right. It's getting confused with which hand is which is not cool. Which is not cool.
Check the structure of model results. The model results fetched from /getResults is likely structured as an object with named keys corresponding to each result set.
No, it's working better now, but still getting errors. Getting some undefined stuff. Get the images. Yeah, why is it calling that? Why is it calling undefined? How do we fix that? Here's the code that we currently have for your reference, and the relevant code from the HTML as well. That should be plenty for you to be able to fix. And while it's generating or not generating, go check out the website. We have some neural network training, basic training, as well as videos of me actually training it. That's a good point. So when we actually publish this, we will have the videos of me developing this stuff. So that will be hopefully a bit easier to follow and understand.
Verify the structure of data returned from the backend. Ensure that the backend function /getResults is correctly generating the paths to the images, accuracy loss plot, and confusion matrix plot.
This is actually working really well now, but no errors in the browser. The problem is that we currently displaying all the runs, whereas my original idea was to have a scroller or a drop down to move through the runs, with the last run being displayed by default when the page loads. How does that sound? We could have like a tab or something. Drop down. Okay. It's regenerating the whole JavaScript. Yeah, this is the problem when it's regenerating stuff. Could be tricky business because I'm not sure generated the whole thing, or looks like it. I expect it to be a slightly longer, 103 lines of code. Yeah, well, I was having trouble integrating. Okay, let's see. I'm not getting any errors. Looks good. The one before the last one is yes, we want to, select a cherry pick, but display everything else as well. So in HTML, when we have select run, we want the default. What's the ID for it? Run select. Run select. We want the default to be drop down. Yeah, -2. -2 will be that one. What? Come on. Actually, we don't want to do it manually in here. Okay, it works really well. We don't want to display the last result. We want to display the one before the last result as default when the page loads. But other than that, everything works really well. Thank you very much. It's really nice when you say specifically what to change in the code and then provide the whole integrated section. 622. So that one is displayed by default. So we have all these multiple runs and still scroll through the original dataset. We have a detailed description. One thing we are missing though is so we have the model accuracy charts, we have the confusion matrix. Okay, that's nice. That works real well. You didn't have to regenerate the code. Now moving on to another thing. everything is working really well, but we just in the results section, would you recommend displaying the misclassified images?
Showing misclassified images helps visualize the specific cases where the model fails, offering direct evidence of its weaknesses. This can be especially useful for debugging and understanding the nuances in the data that lead to incorrect classifications. 2. Improvement opportunities. By seeing which images are commonly misclassified, you can identify patterns or characteristics that may require additional pre-processing, feature engineering, or even adjustments to the model architecture. 3. Transparent reporting. Including misclassified images adds transparency to your results, allowing users to appreciate both the model's strengths and limitations. This can be valuable when presenting findings to stakeholders or users.
Do want to include the misclassified images, and we also want to include the training log, so we know, the text file, the summary of results, and so we know what the settings were used for the specific run of the model training and evaluation.
This web application is designed to provide an interactive and informative platform for exploring and understanding EEG, electroencephalogram, data used in seizure detection through machine learning models, specifically convolutional neural networks, CNNs. The primary goal of this application is to help users visualize EEG spectrogram data, analyze model performance, and understand how different configurations of the CNN impact the accuracy and effectiveness of seizure detection. EEG is a widely used method to record electrical activity in the brain, which is particularly valuable in diagnosing neurological conditions like epilepsy. The data displayed here comes from the CHB-MIT scalp EEG database, a well-known collection of EEG recordings from patients with epilepsy. This dataset has been instrumental in research on automated seizure detection, as it contains both seizure and non-seizure events captured in spectrograms, which are visual representations of brain activity over time. The web application allows users to navigate through these spectrograms, providing a clear distinction between seizure and non-seizure recordings. By displaying these images, users can get a visual sense of the data that the CNN model is analyzing. Beyond data visualization, the application includes various model performance metrics, such as accuracy and loss plots, confusion matrices, and misclassified images from different training runs. These elements are crucial for understanding how well the model is performing and identifying where it might be making errors. A key feature of this application is its ability to showcase results from multiple training runs, allowing users to see how changes in the model's settings, like learning rate, batch size, or the number of epochs, affect its performance. Each run is accompanied by a detailed training log that outlines the parameters used, giving insights into the model's learning process. By exploring these different runs, users can grasp the challenges of developing robust models for medical data analysis and appreciate the iterative nature of machine learning. In addition to the technical insights, this application aims to be a valuable educational tool. It highlights the potential of machine learning in healthcare.
Just a lot of fluff. Why do I need to micromanage?
3. Misclassified images. One of the key insights we can gather is from misclassified images. These are instances where the model predicted incorrectly. By analyzing these images, we can understand where the model struggles and identify areas for improvement. We've included a detailed log for each run, which provides a breakdown of the settings, batch sizes, learning rates, and other training parameters used. This log helps us trace exactly what settings led to each result, making the model development process transparent and reproducible. For those of you following along or trying this on your own, feel free to explore the data and play with different runs to see how the model performs under various settings. This hands-on approach is a great way to deepen your understanding of how CNNs work for medical data and the impact of tuning different parameters. Moving forward, we plan to refine the model further, experiment with more complex architectures, and explore how additional data pre-processing techniques might improve accuracy. If you have any questions or suggestions on what you'd like to see next, Drop them in the chat, and let's keep this discussion going. Thank you for tuning in today, and I hope you found this session insightful. Don't forget to like, subscribe, and hit the notification bell so you don't miss out on our next deep dive into biomedical data science. See you next time.